You're looking at a triangle. What I'm going to do today is to demonstrate to you how to find the circumcenter of this triangle. To find the circumcenter of a triangle, all we have to do is construct the perpendicular bisector of each of the three sides. This side, which is a segment, has a perpendicular bisector that goes this way. This side of the triangle has a perpendicular bisector that goes this way. And the third side has a perpendicular bisector that goes this way. The three perpendicular bisectors will help us find the circumcenter of the triangle. Do you remember how to construct the perpendicular bisector of a segment? Let's review. A perpendicular bisector of a segment is a line or part of a line that bisects the segment into two congruent parts and makes 90-degree angles with the segment. Let's review how to construct the perpendicular bisector. As I have told you before, when you do construction, you only use two things. One, it's a straight edge, which will be represented by the edge of this postcard that I got when I had a stopover in Japan, and of course the compass. This line, which I drew by connecting the two intersection points, is our perpendicular bisector. Observe that the original segment has been cut into two congruent parts, hence bisector. And observe also that this line makes 90-degree angles with the original segment, hence perpendicular. So this line that I just created is called the perpendicular bisector of this segment. Going back to the triangle that I showed you earlier, there are three segments for the sides of the triangle. What we're going to do is we're going to construct the perpendicular bisector of each one of the three sides. So using the same process that I have just shown you a while ago, I'm gonna find the perpendicular bisector of this segment. I don't want the marks to be on the triangle, so I'm gonna make this a little bit wider. That way when I make the marks, they're gonna be a little bit away from the triangle. So there's my first arc. Here's the second one. I'm gonna move to the other side, and now I'm gonna make that intersection and also over here. Now those two intersections will determine the first perpendicular bisector. So with a straight edge, but I'm not gonna draw a long line. All I'm gonna do is just draw this a short segment that represents the perpendicular bisector. Notice that this segment bisects this into two congruent parts. Well, that's redundant. When something bisects, you don't have to say that it's been cut into two congruent parts. So this perpendicular bisector cuts this into two congruent parts, and it makes 90-degree angle with this segment. That's our first perpendicular bisector. I'm going to turn the triangle around, and I'm going to construct the second perpendicular bisector, the one for this side. So using the same process, I don't think I need to change the setting of my compass. So here's my first arc. Here's the second one. Now moving to the other side, I'm gonna make my first intersection, and here's the second one. And using my straight edge again, make sure that I do it precisely. Again, my perpendicular bisector will be a short segment inside the triangle. Now this segment that I just drew is clearly the perpendicular bisector of this second side of the triangle. I have one more left. It's the one that belongs to the third side. So I'm going to repeat the process again. I'm going to be careful not to change the width of my compass. Now where do you think the third perpendicular bisector is going to pass through? You got a guess? Well, let's find out. So here's the first intersection, and here's the second intersection. No. Ooh, wow. Look at that. This segment that I just drew is the third perpendicular bisector. It belongs to this third side. Now, look at the three perpendicular bisectors that I have just drawn. All three of them intersect at one single point. Well, when three segments or lines intersect at one single point, then all of them are said to be concurrent. Concurrent. The three segments are concurrent because they intersect at one single point. That single point is called the point of concurrency. Point of concurrency. And there are many different kinds of points of concurrency. What we have here is the point of concurrency produced by three perpendicular bisectors of a triangle. Once again, this point of concurrency is produced by three perpendicular bisectors of the triangle. This point of concurrency has a special name. It's called the circumcenter. 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 The circumcenter is the point of concurrency of the perpendicular bisectors of the sides of a triangle. Circumcenter.